So today we're going to be starting unit circle trig. And just to give kind of a general overview what the unit circle is a unit circle is a circle that lies on our normal coordinate grid with our normal 1, 2, 3, and 4 quadrants. But because it's called a unit circle, then that means the radius is 1. So what we have is a circle with a radius of 1. So any point that lies in quadrant 1 is positive, in quadrant 2 has a negative x value, in quadrant 3 both points are negative, and in quadrant 4 the y is negative and the x is positive, just like any other normal point. Here's a little zoom in of what that would look like. So here's our unit circle drawn a little bit better right here. What we can do with that unit circle is we can also take that and put some degrees on it. So going back here, we're really doing the same thing. And we're just saying that if I take this unit circle, I can transpose on it some degree values. For example, I know that a right angle is 90 degrees. So I know that up here we have 90 degrees. I also know that a straight line is 180. "90 degrees more than 180 is 270. And then we have 360 degrees all the way around. A little bit more detailed look of that is this guy right here. Now how this starts all coming together is that what we can start doing and why we use the unit circle is to quickly find values of sine and cosine. I'm going to pull up my calculator really quick here. We know that cosine of 30 degrees, if I were to plug it in my calculator, I would get 0.866. If I do sine of 30 degrees, I get 0.5. Now, let's look at where that 30 degrees would lie on my circle. So I'm using both of these measurements right here. I know that 30 degrees would be about right here. If I know that the value of this guy is 1, I said cosine of 30 equals 0.866. Sine of 30 equals 0.5. When I look at this, I need to figure out one of these actually corresponds to be an x value and one of them corresponds to be a y value in the ordered pair that represents this point. Now, if I look and I know that this height of the circle is 1, and I'm thinking about how high up is this, it looks to be about halfway or so above my origin, so about halfway between 0 and 1. So that y value is 0.5, and that x value is 0.866. What we start realizing here is these become our ordered pairs. So on our unit circle, if you ever wanted to figure out what the value of any of these ordered pairs were, you could plug in cosine for x and sine for y. The stronger connection that we gain through these is the fact that we just did triangles and we just talked about all those special triangles. And when I look at this 30 degrees, I know that this 30 degrees lies on top of this x-axis and that I could draw a triangle that moves up. I'm going to pull up another image right here. For our triangles, I know that if I have that 30-degree angle, I can do cosine of 30, and I know that that's going to be adjacent over hypotenuse. Now I know that with my special triangles, if the long side or the hypotenuse is 1, the long leg, the ratio is square root 3 over 2, and the short leg, the ratio is 1/2. When I do cosine adjacent over hypotenuse, square root 3 over 2 divided by 1, I get that cosine of 30 equals root 3 over 2, and sine opposite over hypotenuse equals 1/2 divided by 1, which is just 1/2. Now let's check that against some calculations really quickly. So I know that cosine of 30 is 0.866, but I'm also saying it's square root 3 over 2. If I check that, I get the exact same value. Same thing with my other angles, just to know where those are coming from. You have your 30, 60, 90 reference triangles. You also have your 45, 45, and that's where all of these values here are coming from. So for example, if I did cosine of 45, I would get 0.707. According to this, it's saying that it's square root 2 over 2. So let's check that out. Square root 2, it is the exact same value. So all we're doing here with this unit circle is we're giving you a faster way to calculate trig in 360 degrees. I know that some of these modules are long, but this is one of the most important things we're doing this year. It is something that's very heavily relied on in pre-calculus and calculus, so please try your best and don't hesitate to reach out to any of your teachers if you are struggling with any of the topics. Welcome to Trig, guys.